I bought this cheap little $22 Central Machinery, about 2.5-inch vise. I love it. Very good. But I think I've been made better with some simple modifications, some 3D printing, and some heated inserts. Let's get on that.
Now, the swivel vise does work by itself pretty well. It holds stuff, it can turn 360 degrees, and this jaw can move for holding different size stuff and for different kind of materials. But there's a problem. This bar is constantly banging into stuff. It's driving me nuts. I think I can change that. And just in general, make these a little bit less annoying to deal with. Now, this angle isn't perfect, but it's going to have to do for the time being. I'm thinking something like some clamshell designs. I think that's what these are called. Because I like how they look, and they're pretty comfortable to hold most of the time.
I think something like this with some back, like an extended back to house some heated inserts, will work. And I say that because I've already done it. I kind of cheated with this because I've done part of this project before and it didn't quite work. Here it is. So this is the actual first iteration of the knob. It worked. Didn't work very well though, and I think with some bigger screws it'll have a bit better hold, and with some magnets it'll hold the bar even better. Let's get to the actual caps part of it. So in the future I will be better about actually doing this in real time, but again I kind of cheated with this project. So first I started off with I start off with a very simple hole and square, the hole for the actual like mount of the bar. Then added a hole for the heated insert, added another hole for the through screw. Then I got to the basic form, added some more of the screws, added the slot for the bar to go all the way through, added some fillets, get rid of some material, look a little bit better, more fillets, chamfers. Added some chamfers. That chamfer is for it to slide onto the top a little bit easier. Adding a chamfer to the entry point of like a blind hole makes things go on way easier, in my experience. And then the circular pattern for the actual notches that are held onto. I use black filament. This is a black background. Not very helpful, but added some more fillets on the bottom, and added some more fillets on the actual top so it can actually sit a little bit nicer in the hands. There's no hard, rough edges. Now let's get to printing. Actually, no. Before we do that, I need to actually do some more for redesigning part of it. So there's actually less holes for the heated inserts, and I'm going to try and fit in a magnet in here. Be right back. Actually, let me show y'all something that I think is pretty helpful for some of these things, especially for 3D printing. I use Obsidian to just jot down notes, not jot down ideas that I have, but I also use it for tolerances for 3D printing. So for 3D printing, there's tolerances. There's tolerances in every single machine, every single tool. So if I design a hole to be 10 millimeters exactly, like this one here. Oh, this is hard, I'm left-handed. If I design a hole to be 10 millimeters exactly, it's not going to fit this. Now, if I want to design it to be 10.1 millimeters, I think that should be enough. But actually, up here I have that you need a 10.3 millimeter diameter and a 2.9 millimeter depth, just so there's clearance. I might make the depth a little bit shorter so the magnet sits either flush with the surface or a little proud from the surface, but that's just a general idea. Keep in mind your tolerances for your 3D printers. They're all different. My 3D printer is pretty good. I love my 3D printer, and its tolerances sit within 0.2 millimeters, 0.1 to 0.2 millimeters, depending on orientation. It's pretty good. Most 3D printers didn't used to be like that. Anyway, back to SolidWorks. So since this is going to need to be if you can believe it, I have my SolidWorks license. It is just not showing here. Now, I'm hoping that I want to move my camera. Anyway, I'm hoping that fillet is enough. Like there's enough material there for it to not matter too much, but I am going to try that. Also, this used to be a 3 millimeter, an M3 insert, but I just didn't realize how tiny M3s were at that size. So now we're going to be using M4s, a bit more substantial. Now I'm going to say this is an STL and just send it onto the printer. Now, while it would be best practice to add some supports into these spots that are definitely going to need it, like up here, this overhang, and more, the one I'm worried about is this hole right here for the threaded insert, but it is so hard to get those supports out, so I'm just going to hope and pray that it'll be enough. Knob is done, feels fantastic in the hands, looks good, print was good quality. So now I'm going to insert heated inserts into here with my heated insert press, which is going to be the topic of the next video, I imagine. A little hard to see in this light, but I added two 10mm by 2.6 magnets set in here. If you can see it, but you can definitely hear it. And an M4 by 18mm screw. Now, the moment of truth.
Nice tight fit. Now let's tighten it down. Good. And the magnets are holding. I still have access to torquing it down when I want to, but yes! That worked fantastically if I say so myself.
Now the main vise knob is actually working fantastically. So now I'm gonna start to tackle the other two like side knobs that access the rotation jaws and the actual like swiveling of the jaws. Let's see what happens. Okay, now that the cat is done for the side knob, I'm gonna send it off to the 3D printer. So it turns out the one I first designed for the side knob, screw works great. Like the M3 will hold on to that part perfectly fine, but that little magnet is way too tight of a fit. It's almost impossible for me to get it on. So I'm just gonna reprint it.
Here's the knob. Magnets are holding the bar in place just like it is on the big one. I can turn it, torque it on down, and the bars aren't in place. Let's focus on this one now.
So I have the new knob on. It works fantastically. The magnets are holding the actual bar in place. So I'm still getting the rotation. I can turn things. I can pull out that when I need it. We're all good. Now, I'm going to start on the bottom rotation swivel, and I think I might have found out an idea for that. To stop it from like bashing in, like the head of the vise from bashing into this knob, I shortened it by a lot. And I didn't even, this can barely be classified as a knob at this point. I'm mostly just doing this to keep the magnets, like to keep the bar from shifting, but let's see if that works.
Now, the moment of truth. Did I do this well enough so that it'll pass the head? I would say yes. Yes, it does. Now we got all three knobs. Wonderful. Wonderful.
Now that I have all three knobs like working exactly how I want it to, I would say that this project is done, and it's a success well done, if I do say so myself. One of the things I love most about industrial design is trying to improve on the quality of life of products, of just trying to figure out pain points of products. And while I don't think like this is an absolutely necessary modification to get any vise to work, I think it makes it just that little bit better. That makes it more of a joy to use, and I think that's something that designers, and I hope to one day be a designer, something we need to focus on is that fact of what's the benefit of it being necessary versus it making some life better, making a part of life better, some usage any bit better. And I think that's something